So in question number 4 we have to find the correct equation based on this graph. So here the letter M represents a picture that shows a boy. So first we gotta set up the rest of the components. So we got, in this case, mg sine of alpha, because it's respect with this angle. Then in this component, let's put it a little bit longer. So opposite of the angle beta, we got not mg, but the force going upwards, the force F1 sine of beta. And adjacent to the angle beta, we have same force, but in this case cosine of beta. So to find the correct equation, we don't know in what direction the mass m is going. So let's say in this case the acceleration we're going downwards. So that means that this part, let's call it x direction, we said that this side was mg sine of alpha. So this one is going to be positive. So let's write it right here. It's going to be Newton's law. So for the x direction, we got the positive mg sine of alpha. So that means that this side is parallel to this one. In this side we found, and we said there was F1 sine of beta. So that means that's going to be force 1 sine of beta, but in this case it will be negative as it is going against the acceleration. So it's going upwards and the acceleration is going downwards. It's opposite, so it's a negative. Now that we have set up the equation, we can solve for A. So we're gonna do some algebra here. We're gonna do F1 sine of beta plus mg sine of alpha equal A, and this whole thing divided by m. Now we can separate into two fractions. So F1 sine of beta divided by m plus mg sine of alpha divided by m equals acceleration. So right here we could say F1, the force 1, divided by m sine of beta. Right here we can cancel out the m's. We got g sine of alpha equal to acceleration. So that should be our final answer. One little mistake. At first we said it was negative F1 sine of beta. So we just keep putting the negative sign. And this is the final answer. Negative force 1 divided by the mass times sine of beta plus g sine of alpha equal to the acceleration. Now this acceleration is the acceleration of the boy in the direction parallel to the plane.